Hello, welcome back to another episode of Math with Haas. You're watching Precalculus Season 2, Episode 18, Part 2. We're continuing our investigation in trigonometry. In particular, we're going to cover another example of how to graph transformations of trig functions. So, let's go ahead and make up something. About y equals negative 2 cosine of what do we want to do? I guess we can be weird about this. Pi of x minus 2 pi. Alright. So let's recall our steps that we talked about in part 1. So steps, or step, what do we do? Step 1. ID transformations. So it is good to first ID our transformation so we know what's going on. And also writing clearly. So let's note that the general formula is a cosine of b of quantity x minus d and quantity plus c. So it is important that we consider this form for graphing our function, because when we look at what's inside the cosine, it actually does not match the original form here. So notice inside our cosine is the following. We have a pi x minus 2 pi. That is not the same thing as b times x minus d. So if we do not catch this distinction at first, we would have said, well, b is equal to pi, but d is equal to 2 pi. And that, in reality, is wrong. So, first step is we need to actually rewrite this. So let's delete all this. Alright. So we're going to make a caveat here. Rewrite equation if needed. So step 1 just got a little more complicated. So to rewrite this, what we need to do is factor out this pi term here. Okay, because that is the common term. So if we factor out the pi, then we get x minus 2. And then that shows us really what's going on, right? So we can see that actually, before we do that, we should use different colors. So we can see a is equal to negative 2. B is equal to pi. And then we got C is equal to, is it positive or negative? Well, remember, when we see the negative here, that means C is at, or actually this is D. C is 0, so that's confusing on my end, I'm sorry. So D is equal to positive 2. It has to be positive 2 because this negative right here is actually already being taken into account. So let's highlight that negative. So this negative right here is already taken into account by that general formula. So that means once we ignore that negative, we can see that D is positive. If there is a plus sign highlighted there instead, that means you have a double negative and D would be negative. Alright, so that's why D is positive. So when we consider A, this tells us that the absolute value of negative 2, which equals 2, is equal to the amplitude. So we have an amplitude change. But we need another color. It also tells us that since A is negative, there is a reflection across the x-axis. Okay, so a reflection across the x-axis. And let's see here. B equaling pi tells us that the period is going to equal to 2 pi divided by pi, which is 2. So we have a period change where the period's now 2 instead of pi. And when we consider D here, since D is positive, we have a shift right 2 units. So there's actually 4 transformations here. So step 2 was graph the original function. If we can spell original. So this is step 1 we just did. Alright, so step 2. In fact, we're going to move this down here a little bit. So cosine, we actually want to start up here. So cosine goes like this. You start here. So this would be pi over 2, pi, 3 pi over 2, and 2 pi. So we go down, and then we go up, and we end where we started. Alright, so there's 1, negative 1. Alright, so there's step 2, the original graph, and then step 3 is going to all be done on the same graph here. So step 3, in the last video we said start with the, so we want to do our graphs with it adding on 1 transformation at a time to the original. And then we wanted to start with what's more complicated and then end with the least complicated transformation. So the order I suggested was the period and horizontal shifts first. So do those first, and then vertical shifts, and then amplitude, and that leaves lastly the reflection. So this is the order I recommended that you do. And reasons for that I stated in part 1. And the basic idea is you start with the most complicated and end with the least complicated, so you can get all the hard stuff done first. Alright, so let's see what color we had. Okay. So we are going to start with, how about, we're actually want to start with period change. So the reason why I want to start with the period change is this. So if we were to do the shift right 2 units first, notice it's not in terms of pi. So when we look at this graph here, I have to take each of these values and subtract or add 2 to it. So whatever pi is, right, 3.14 plus 2, well, that's not a very nice number to work with. And we want to have a nice life, which means we want nice numbers to work with. So to have nice numbers to work with, notice that the period is in terms of just nice numbers because the pi is died out. So if we start with the period change, then it'll actually make our life, well, easier. So if you watched the last video, I said that I wasn't sure whether horizontal or period would be better to start off with. In this case, definitely starting with the period is the easiest, will make our life easiest. So the period is equal to 2. So it's, in a sense, what we want to do if we were to think about all these values here, the original 5, right? They're all being divided by pi, okay? Which means they're all going to get smaller. So we take pi over 2 divided by pi, that's going to leave us with a half as our x coordinate, right? That pi as our x coordinate is going to become a 1. And we get 3 halves. And this becomes 2 as we said before. So, when we think about our value a half, let's see here. Let's make sure. We'll bring up the calculator so we can see what our thought is. So when we think about pi over 2, pi divided by 2 here, we see that it's approximately 1.6. That means for our first two values, our first 2 points are actually going to be in between 0 and pi over 2. So when we are at a half, so I'm going to just call this 1. We'll call this a half. When I'm at a half, I'm actually at, this is the x coordinate's at half, but the y coordinate is going to be at 0. So let's see here. That means we're going to be right here for a half. So the original y coordinate that was associated with the x equaling a half from the original graph is going to carry over to our new x value. So when we have x is a half, that means our y coordinate is going to be 0. When we have y equaling pi, that was when x was pi, y was -1. That means when we divide x by pi, we get at 1. So at 1, we're going to be at -1 down here. Now, we really don't have space to cram all this, because I have to cram 1.5 in here as well. So here we go. Here's 1.5. This is really not going to look nice right now. So there is, oops, let's delete that. So 1.5 is going to be right here. It's going to act just like the 3 pi over 2. So, and then that leaves the value 2, which will be right over here. Now it's going to act like the 2 pi. So we have the same y coordinate as 2 pi, which is 1. So it's up here. So this is really smushed together. Here we go. Alright. So this blue line takes into account y equals sine of pi x. Now you could have also just made a table of values, right? What happens when you plug these values in. However, I just kind of like to think about what happens to our main 5 values, and namely what's happening to them instead of being divided by pi. Now, we divided by pi. Now we want to think, well, we got to shift right 2 units, which means each of these numbers we're going to add 2 to. So if we take a half and add 2, that's 2.5, which is right here. So we keep the same y coordinate, it's just the x coordinates changed. So when we're at 0, we're at 2. And then at 1, we are actually at 3. So 3 has to be right here, because it should be right next to pi, since that's 3.14. So we can see my scale's off a little bit. Make sure we can fix it. So it's, there we go. So there's 3. We had a point here. We had a point here. And then, so when we are at 1, we are at -1. So that means at 3, we are right here. And in fact, I just noticed that this point down here, on the original graph, that was off. So then, so that's another my bad. So let's see here. Here's 3.5 right here. And then we need 4. And let's verify now. So this is pi divided by 2. So if we multiply by 3, let's see what we got. This is 4.7. So that tells us 4 has to be over here somewhere. Oops, we don't want to put the point there. Because we know this point has to be here, and here is 4. Alright, so now we can make our graph. And now I think that looks a little better than the blue one. So the green one here, that is y equals sine of pi x. Oops. This is sine of pi minus 2 on dx. So that takes into account the shift right. All we did was take each of our x values here and add 2. Now, let's see what we got. We got to take into account the amplitude change. So, with the amplitude change, we know that the midline is at y equals 2. And since the midline is at y equals 2, we need to draw a new midline. Wait. No. Delete that. I got that mixed up. Our midline's at 0 because C is 0, right? We don't have a shift up or down. I was just being tired. Alright. So, since our midline here is at 0, we want to identify where is the midline, because when we think amplitude, we have to move up and down 2 units now. So, for our graph here, this point and this point, those will remain the same because they're at 0, but the other points we need to increase from a distance of 1 from our midline to 2. Right, so just note midline is at 0 because C is 0. So if we were to go up 2 units straight on up, that would make us stop right here at this point. So that is where our first new point is, right here. And then we can note, we'll have that value over here as well at x equals 4. When x is equal to 3, we now have to go down 2 units to -2. And so now our graph looks something like this. Alright. So this is our graph of 2. Oh, why am I? So I just noticed that I've been writing sine this whole time here, and that needs to be cosines. Another proof that I am sleepy. Alright. And also a sign that I'm not going to make another math video today. So here we go. It's looking good. So we got sine, or we got our cosine function. And so now we've taken into account the period, the horizontal shift. Now the amplitude. So lastly, we need to take into account also the fact that A is negative, so we have the reflection across the x-axis. So we'll change to dark purple. So what this says is, again, these 2 points will remain the same because they're at 0. But now what was positive becomes negative. So the positive 2 for our y value is now going to become a -2. And our -2 value will become a +2. And so we get this flip-flop. Now we get this situation here. And there is our final lovely graph. And we'll highlight our final answer just to make it a little more obvious that that's our final answer. So that purple line takes into account -2. cosine of pi times quantity of x minus 2. Alright, so that is, in a nutshell, a nice example working through one of these graphs. As you can tell, it takes a little while to do them, so just be patient. Thank you for watching this video. Please subscribe to our channel. Consider supporting us on Patreon. Thank you for joining our party, and I will see you next time.